Hi, I'm Anand. If you're preparing for a Java interview, you probably already know the definition of volatile keyword. You know the standard answer. Volatile prevents a thread from caching a variable locally and forces it to read and write directly from the main memory. But here is the catch. Knowing the definition is easy, but actually writing a practical working example is exactly where most of us get confused. We are going to fix that today. In this video, we are going to discuss volatile end-to-end with a super easy practical example so that you never forget it again. Let's jump right into the action. So the definition, one more time, let's see. Volatile is a strict instruction to Java that says never cache this variable locally, always read directly from the main memory. So this is the standard definition. So let's see what happens in general. So threads love to secretly copy variables into their own private memory, which is also called as CPU cache. And this they do just to work faster. So this makes threads to work faster, and it's kind of a optimization. If one thread updates the variable, other thread won't see the change because they are still looking at the own outdated private copies. That means, let's say there are two threads parallelly running, and if one thread updated the value of a variable, but at the same time some other thread is using that variable, so the other thread will keep looking at the old value, which is the cached value, and our update done by the previous thread will not work. Yeah. So what is the solution for this? So the solution is volatile. By marking a variable as volatile, you take away those private copies. You force every single thread to go to the shared main memory to read or update that specific variable. It guarantees visibility, meaning if thread A changes a variable, thread B is guaranteed to see that exact change immediately. So let's go right into the IntelliJ. So I have a class worker thread implements from runnable. I have a boolean is active is equal to true and int count. And the run method of this worker thread is doing very simple job, which is just running a while loop based on is active. As of now it's true, so it should be keep running and increasing the count. So it's fairly simple thread. And let me go to the main thread. So if you see here, this is a main thread, and I have a main method here. So main method is also a thread which is called as main thread. And inside the main method I'm creating a object of worker thread, and this worker thread I'm passing as then to instantiate the class object. And once the thread got created at this line, I'm doing thread.start. Once the thread.start happens, the thread scheduler just gets the this thread registered, right? This worker thread will be registered into the thread scheduler, but there is no guarantee that this new thread worker thread will get chance of execution because it depends on thread scheduler, like which thread should get the chance of execution. There is no guarantee that this worker thread will get a chance of execution immediately. So to make sure that worker thread should get chance of execution just after this line, I am keeping this current thread, which is the main thread, into sleep for 10 milliseconds. So this thread will go into the sleep, so the other thread will get chance of execution. So let me go back to the worker thread and see one more time that once this thread will start the execution, it's just doing one thing, which is increasing the counter. Yeah. And which is relying on is active variable. So it will keep running and running and running. But at some point, the thread switching will happen, and main thread will get the execution chance again. So once the main thread will get the execution chance, then it will start. The execution will start from line number 12. Yeah. So at line number 12, we are changing the worker dot is active is equal to false. So we are changing the Boolean value from true to false by using which the worker thread was running this loop. So as soon as this worker dot is active becomes false, ideally the worker thread should stop its execution and we should get this into the console. Stopped worker thread count is whatever count value will be there at that point of time. Yeah. So this is the expectation. Let me come back to main thread. So again, as soon as the worker dot is active becomes false, the worker thread should stop and we should get the counter. Yeah. So just to make sure that this line number 12 got executed, I am doing a sysout to just mentioning that flag change to false so that we can see this happening in the console. Yeah. So I have started the program now and you can see the console is showing flag change to false. That means the main thread completed its execution, which is at the line 13. This particular sysout is getting printed here, but still the worker thread is keep running. You can see here the program is still running. And if I go back to the worker thread, you see we have a sysout here to show that once the run method of this worker thread will complete this loop, and once the execution will come out of this loop, we should get a sysout saying that worker thread stopped and the count is this much. Yeah. So even after the main thread changed the flag value to false, the loop is keep running just because the while loop is still using the stale copy of is active, which is true inside the cache. Right? So that means even after the flag got changed to false, the while loop didn't got the updated value. So this is the problem. But here the question comes, why the count is not reaching to its max, right? So what is happening here is that because the while loop is keep running and never stops, the integer gets pushed past its maximum capacity. When that happens, it overflows, instantly resetting the lowest negative number and counting from there. That means once the count reaches to the integer dot max, it starts from integer dot min again and again. So, like because of that, the while loop is keep running and running. You can see as we are discussing, even now the program is keep running. So, I have explained you the problem statement, and now we will see what is the solution. But before seeing the solution, I want to show you how the overflow happens. To show you that the overflow is actually happening, I have added one if condition. If count is equal to integer dot min, just print overflow happened and the count value. So what this means is that once the count reaches to the integer dot max, immediately it will fall back to integer dot min and then it will start again from there. So once that happens, our condition will get passed and simply we will get the count value at this place. So you can see I have ran this and this condition got satisfied for me and I'm getting the overflow happened. Count is negative some integer value. The integer dot min value uh, precisely. And then the after that the worker thread got stopped and then whatever the value we are seeing here in the negative, we are getting here. To fix this, let me make is active to volatile. Now, instead of while loop reading is active from local cache, the is active value should be read directly from the main memory, which was already changed to false by main thread. Now, let me run the program. Now, you can see that we are getting the log as flag changed to false, and this time we are getting stopped working thread, and count is some positive number. Definitely we didn't hit the this if condition where the overflow was happening and the count was getting reset to the lowest integer value. So now we can say that is active is getting read directly from the main memory and not from the cache. So this is it. Please let me know your thoughts and ask me any questions if you have in your mind, and I will try to answer them in comments. And thank you for being till the end of the video.